totally have this recorded too. I don't mind that at all. I mean, that's why I have the YouTube stream. And then the third part is saying based on the second part, okay, based on how registers are getting updated, which one of the instruction resembles this one the most out of the instructions that we have already talked about or they're in the opcode table. So you just look it up and find out, okay, this one does seem to update the program counter in this specific way, and it's the quote-unquote JMPI instruction. Now, obviously, different people get different questions. Okay, so yours may not be JMPI. Yours can be, I think the other one was the LDI instruction, and then there are also the conditional branch instructions. But we went through the analysis of all of those instructions in class, as well as the process of answering question number 2 when I talked about the sample second exam. And then the last question, the last part of the second question has to do with looking up the opcode. So obviously, if someone gets the third part wrong, the last part is also going to be wrong. So that's the second question. And then the last question, I was actually surprised that not as many people as I thought would get it correct. Most people got the first part right, which is converting the value into a binary number. So most people got that part right. But it would seem to me that a lot of people did not read the question carefully or made assumptions about what I was asking. Either way, most people just converted it into a regular double precision floating point number when the question was saying that what if somebody made a mistake and instead of using the correct double precision floating point number format, that person used 7 bits to represent the biased exponent and also use 63 in decimal as the bias. That was what the question was asking, is somebody made a mistake. And based on that mistake, what would be the bit pattern of the representation? That's the first part. And then the second part is to say, okay, using that bit representation, the wrong bit representation, if somebody is to send this to a computer that would assume this is using the proper double precision floating point number format, what would be the actual value being interpreted? That was the last part of the question. I will say that most people just made the assumption that I was asking about double precision floating point number format, and they just gave me the bit pattern, and that was not what the question was asking. So, I mean, that's what I saw when I graded the exam. So, moving on to the last exam, which is the final exam tomorrow. That is going to be so I'm showing you, okay, if you watch the video that I recorded earlier, in the morning, that is the solution to the actual final exam from spring semester. So my question is, are there any questions? I cannot give you the answer to that question because I am not you, and I certainly do not have a crystal ball for the future. But I can tell you that with all the explanation and with me not actually looking at the solution from the final exam of the last semester, the entire video to show not only the correct answer, but also a verification by running the code through one in C, so that we can actually observe the behavior in C in a certain way, and then run it through the trace analyzer and look for the one thing that that's a marker, that's an indicator that the program is probably working correctly. So with everything done and said, it took an hour. and you have 120 minutes in the final exam, which basically it's 2 hours. So I can only give you the facts, okay? I cannot give you a projection. I cannot promise anything, but those are the facts. But it is up to you to interpret those facts. And I really cannot answer the question. Is it going to be hard? I don't know. I am not you. I cannot assess the test from your perspective. I don't know how much of the material you guys are understanding. I don't know how much of the material you think you're understanding, but you're not understanding. I am not a mind reader. So that's the best I can do. Yes, go ahead. Um, okay. Then let me ask you, how can I ask tricky questions in a class like this? I mean, that really is a question. That is correct. 120 minutes. I'm answering the question in the text channel because that's what I just said. 120 minutes, 2 hours. Okay, so getting back to the tricky question kind of part. Um, this is a class about math and logic. And as a result, I think it is pretty hard to make a quote unquote tricky question because everything is just based on logic. I mean, it's not like I can make optical illusions so that oh, this is a sleight of hand. Okay, the coin disappears and then it reappears over here. I cannot do that, right? I mean that's just not possible when you have a class that is based on logic and based on math. So in terms of the assessment of the final exam, I gave you the final exam from last semester. So use that to help yourself evaluate whether it's going to be difficult or not. I mean, that's all I can do. I mean, that's all I can say because I am not a mind reader. I cannot tell from your perspective individually whether the test is going to be hard or not. All I can tell is, and this is factual as well, is I can go back to the YouTube, videos, that I have recorded, and I do not get questions in certain places, and I said, okay, I'm going to pause here, I'm going to stop, because I think there will be questions, and there were no questions. Okay, not even someone saying I don't know, what to ask. So I have no feedback whatsoever, and with that kind of a lack of information, I absolutely cannot make an assessment for you guys in terms of the level of difficulty of the exam. What I can do is to go through the explanation, especially for those of you who have already watched the video from this morning. I don't know how many of you took my recommendation to go back to the programs that I did in class and actually put in the comments as much as you can, just based on your understanding, and then go back to the video and see how I explained those instructions, what those instructions, are doing. and try to make sure that you understand, what those instructions are connecting. What are we doing on the stack? What are we doing to the registers? What does this mean when we increment, register D? What does it mean when we decrement register D, and so on? So I keep saying the same thing, okay? Because if you listen to my lectures, it sounds like a broken record because those are exactly the same concepts repeated over and over again. So I was trying to use different sample programs in different type of scenario to illustrate the same concept. I'm not sure. I don't think I'm answering the question, but I am only presenting the facts and what I know. Absolutely. Coffee, tea, doesn't matter. Put it here. hmm I think I understand what you're saying, but I cannot understand why or how it can be interpreted incorrectly. Let me read the sentence. The first part of this question is to figure out this value, how this value v is represented as close as possible as an incorrect in italic double precision floating point number. Compared to the correct format, this incorrect format has the exponent taking up 7 bits with a bias of 63. Because of this error, the fractional mantissa has 56 bits. I'm not really sure how someone can misinterpret that part of the question. And then the next sentence says, use the following space to show the conversion of the value v into this erroneous floating point number bit pattern, step by step. I mean, I'm just reading from the question itself. I'm not passing judgment, but I really cannot. I mean, obviously, I cannot tell, uh, if there's a quote unquote trick in it that some people can see, an optical illusion that I cannot see. Uh huh. Go ahead. No, I don't really know what you mean, but because those terms were introduced in class. What the bias means, what is the exponent, and why we have a biased exponent. Those are core to the understanding of what a double precision floating point number is. And I went through a few examples to illustrate, what the bias is, how it is applied, and so on. So, in many cases, I don't even see the quantity of 63s anywhere in the answer. It is almost as if those sentences were not even written. So that's basically, what I saw when I grade the exam. And as far as running out of time is concerned, I different people work on these exam questions at a different pace. So I can't really say anything about whether people should be running out of time or should not be running out of time. I mean, I think if these topics were well understood, they really the exam there should be enough time in 80 minutes to answer all the questions. And obviously, that may not be the case for certain people. They may not have enough time, but I cannot understand why there was not enough time to answer all the questions. So, and this is not a very good use of the time today because, if there are any questions about the exam tomorrow, I think it is a better way to spend the time is to talk about the concepts involved in the exam tomorrow instead of going back to the previous exams and talk about those. So I guess my question is, are there any questions about the sample exam, the sample final exam from last semester? I'm going to pop it up on the screen just so that you guys can see it. Yes, go ahead. Mm-hmm. Okay, so let me show you what the program looked like. I think it's the oh, okay, I think I just went past that. That was actually explained in the video as well why I chose that location. All right. So even if people do not fully understand, what the C code is doing, they can put in breakpoints, right? They can put a breakpoint, let me turn on the line numbers. Okay. So I'm going to go back and explain, how this part may not even be relevant, but people can look into this conditional statement, and to test the program, we have to basically insert certain points and go like, okay, where did the program go when I ran the program? So line 23 is a good point to to place a breakpoint. Line 28 is also a good point to place a breakpoint. Because eventually, okay, so let's go back to this code here. So this code is going to change something, and we are looking for some changes that is observable so that we can verify that the C code and the assembly code work the same way. So that means we should be looking at assignment statements. Now there's a hidden assignment statement in auto increment, but this auto increment is only affecting a local variable, so it's not going to be very helpful in terms of telling us whether the program works or not. So we should be looking for something that would be updating something that is not a local variable. In other words, it is updating something that a parameter is pointing to. So when you look through this program, there are very few places where it would modify something that a parameter is pointing to. This is kind of the only place that you can find something like that, because it is modifying something that is not a parameter and not a local variable, but what a parameter itself is pointing to. That is the significance of line 23. So so I'm going to repeat this, because I did this earlier in the morning as well. So when I use GDB to look through the execution of this program, I looked at the listing of SD insert and look up the line that actually made that change, which is line 23. So when I put a breakpoint on line 23 and I run the program, we can see that how it got it got to that point. And when it got to this point, the point as a parameter has this particular address, which here it only tells us that it is n2 plus 16, which means it is 16 bytes past n2 as the beginning of the structure. So in the video that I released this morning, I also went through a process to find out exactly what member of n2 got changed, and that turned out to be the second element of the array P, which is a member of the structure that the point is pointing to. So So that is significant because that portion, the logic of the assembly code should not change, even though it is on a different type of architecture. Uh, the trick of making only one return point in the TTP-SM code, while the C code had 3 return statements, was a bit confusing. Okay, so all right, so getting okay, let me finish why I picked that location first. So that location, which in so using BT, we can go back to main, but it's actually not necessary because we can now say print what is the address of the following, and we want to look at n2.p bracket 1, and we can see how that is matching point as a parameter. And since we're updating whatever point is pointing to, so we now know that n2.p in square bracket 1, that is the item being updated. And because the logic of the assembly code is supposed to resemble the logic of the C code, so that means from the perspective of the assembly code, the same thing should be affected, should be updated. And that is why I chose to monitor that location when I looked at the trace, looked at the trace, so that I can verify that the program does work correctly. And yeah, register A always contains the return value. Okay, so I think I can now move on to Paul's question or Paul's concern. Yeah, go ahead. Oh, you're welcome. All right, so let's go back to Paul's point that the C code had multiple returns, and in the assembly code there's only one. That is that's because there are 2 returns in C, and they are combined into one single statement in C. In C, the return statement has actually 2 jobs. One is to specify the return value, and the other one is to actually in control in the sense of execution, to continue execution back in the caller. Those 2 things are combined in the C return statement. In assembly code, they do not need to be associated. So in the assembly code, so this is the one that is done already, that was released in the morning. So anytime, so I basically consolidate all the control structure, to one single point of return, which is all the way at the very end of the subroutine, which is right here. So this is how I consolidated all of the control return, basically continuation, back in the caller, all the way to the end. And there's a very good reason to do that too, because unlike in C and C++, where you do not have to worry about the deallocation of the local variables, in assembly you do. So by consolidating every single one of those return statement to one single point at the very end of the subroutine to continue execution at the caller, I only have to make sure that there's only one place that I have to deallocate the local variables and then continue at the caller. So that is the reason why I consolidated in terms of control, every single return statement go all the way to the same point in order to continue execution at the caller. So but it doesn't address the issue that they are returning different values. So in the code of the body of the subroutine, I still preserve that. So before continuing all the way to the end of the entire subroutine, I specify the correct return value in register A, which is what Folin just mentioned in the text channel. All right. So Alexander, you mentioned something about partial credit. Partial credit has always been an interesting question. I spent actually a lot of time to think about how much partial credit to give people. I understand there's a difference between an assessment in a school or college setting, as opposed to work. When you're assigned a certain you know program specification. Because in the latter case, at work, there's no partial credit. If your program doesn't work, if it does not meet the specification, it does not meet the specification. It is really binary when it comes to a work environment, as a professional. So this is not a this is not a situation like that, and that's also partially why I break a question up into small pieces so that people can get one piece right, even though the rest of the pieces may be wrong. So you can consider that as a part of how I assign partial credit. And then the other part is I think there are programs out there that can actually look at a particular value and give you the binary representation in a double format. I demonstrated the process to do that as well in class. So being able to replicate that process really does not mean that person understands, how things are represented. So that is why, when I evaluate whether to assign partial credit or not, I kind of have to take all of those, factors into consideration. All right. Yes, people are still talking about the second exam. All right. So, any other questions about this particular program? And once again, my recommendation, from this morning's video is to go through this and figure out, track down what each register has and how the value of that register correspond to the C code on the other side. Because ultimately, it is the connection between the assembly code and the C code that is important in the final exam. So do we have any questions about the assembly language code? Go ahead. Mm-hmm. Go ahead. You mean this part here? Okay, so this code, so are we talking about this code on the right hand side? Insert while begin, right after that? The three pushes? The what? Sorry? The LDI statements? Okay, so let me explain that part. This trick was actually used in one of the sample programs that I presented. Anything that has multiple arguments can potentially need something like this. All right, so to understand why this needs to be done, it is important to understand what is on the stack. So this is something that you can also do on your own, is to make a picture of what the stack should look like. And I'm gonna change the code to okay, this is the right place, but I want to also make the C code to be at the right place too. All right, so we are basically talking about the pushing of n new node endpoint. There are no calculations whatsoever. We basically just pass whatever we got onto SD insert over here. So from the perspective of the callee, or the caller, okay, let me see. Let me think about how to call this. From the perspective of insert, okay, that's the best way to put it. So from the perspective of insert, the last parameter is point. The second to the last one is new node, and then the first parameter is oh, okay, I forgot one thing. Where is? Oh, okay. So there are only two. Because there's only new node here. And then we have the return address, and then we have the local variable n. So from the perspective of the insert subroutine, this is what is appearing on the stack. Once we have allocated the space for the local variable, this is at the location d plus 0. So column B is the address corresponding to the items. Yeah, go ahead. Oh, because of okay, I am going to make myself disappear. All right, so there we go. All right, so this is d plus 0, which is an offset of 0 from where the stack pointer points to, which means this is exactly at where the stack pointer points to. This is d plus 1, d plus 2, and this is d plus 3. Okay. All right, so from the perspective of calling SD insert here, we push point, over here, because when we push, whatever we push is at a lower address, so we keep going down in terms of memory addresses. So when we push point, point is going to be replicated here. But remember, when we push something, D is also updated. So that means this is now D plus 0. Okay, so the offset that we have to N, to new node and point, they are now all off by 1 because N is now at the location D plus 1. Return address is at the location D plus 2. So let me just update all of these so that the picture does. Oh, okay, I updated it incorrectly. D plus 2, D plus 3, and then D plus 4. Okay, so this is the reason why we have the extra 1 plus over here, is because by the time we want to push new node is no longer 2 bytes away from where the stack pointer points to. It is now 3 bytes away from where the stack pointer points to because we just pushed an argument on the stack, and the stack pointer always points to the last thing that we push, and hence we need to add an offset of 1 compared to how we define the label. Now, when we push, after we push new node, okay, so after we push new node, which is an identical copy of what was on the stack at this location, once again the offsets are all changed because when we push, we are actually changing the stack pointer in the process. So at that point, this is what the stack looks like. Okay, the stack pointer always points to the very last thing that we push on the stack, which is a copy of new node as an argument so that we can call SD insert. But when you look at how the labels are defined, they are now 2 bytes off. Okay, so when we want to push N on the stack, N is no longer where the stack pointer is pointing to. It is now 2 bytes off from where the stack pointer points to. That is the reason why we have to compensate by using the 1 plus and the 2 plus here. So the most important part is not to just memorize and say that, oh, okay, so when we push multiple arguments, we just blindly add 1 plus and 2 plus to the offset. That is not a good way to do it. A good way to do it is to understand what the stack looks like, how we are pushing, how we are getting to the value of the items on the stack, and how we are pushing those on the stack. It is all boiling down to the concept of how we use the stack pointer, which is register D, how we utilize the stack, how we define the labels, and the entire situation can change if I change the approach or the strategy of how I push arguments on the stack. All right, so I think that might explain, that might answer Paul's question. We probably do not, a second register would not solve this problem because the problem has to do with the stack pointer itself getting changed. The problem did not happen in the other subroutine. In this particular, over here, I think it probably had the same issue because we have point. This one does not need any adjustment, but this one does need an adjustment, and so does this one. So when we go back to, in the assembly code, go back to the loop inside SD insert, let's see, does it have the same issue? I'm looking for the call to the subroutine, which is in the else case. Yep, this is the else case. And okay, we are not there yet. We have to go up a little bit. There we go. So it does have the same thing. You can see how, the first argument, which is I, does not need an offset because at that point the stack pointer is still pointing to um, the local variable, the last one that we allocated. And when we get to new node, actually we have to, yeah, new node is just new node itself. It need a 1 plus, and when we get to n, which is the first argument to push, we needed a 2 plus over here. So I think that's probably, I mean, did I explain the necessity of why we have those offsets, the 1 plus and the 2 plus? Okay, all right, cool. All right. All right, so remember earlier I said, the tracing of the C code, running it through GDB may not be actually needed. And that's because, I think realistically speaking, it is probably a better idea not to start with tracing the code in GDB or to use the trace analyzer. And instead, if this is the kind of question you're getting tomorrow, the best approach may be just to analyze the C code and match it to the assembly code and find out what may be wrong with the assembly code. So I would just go with that, which is what I did this morning. Okay, I just did a static analysis about the C code and how the assembly code looked like before my modification, and noticed some several problems within the program, and then fix those problems. Because I don't really need the program to be 100% functional, but I do want to see how many of the flaws or the faults you can find from the code that is incorrectly implemented. All right. Yeah, so Paul is correct. That was actually my point as well, is to start with the mechanics, because you may not have enough time to try to understand exactly what the C code is doing. But this class is not, well, okay. This class assume that, okay, assume that you understand the C code, but this class, the focus of this class is how we translate the C code into the assembly code. So I would focus on the translation part, and when you watch my video, okay, Paul has done it already, and I think many of you have done it already. So you have to kind of look at how I analyzed the C code, and then understanding what the C code is supposed to do, look at the assembly code and ask the question, is the assembly code at that portion of the program doing the same thing as what the C code should be doing? And if the answer is yes, then we're good. If the answer is no, then we have to figure out what is wrong with the code and how do we fix that code. All right. All right, so you can start with, because the analysis, does not actually depend on the call order. So that means we can just read the program and analyze the program from line one, just keep going forward. You might also notice that when I see a control structure, like a conditional statement, I check the control structure itself first, okay? Because if in the case of there's a if then else, I need to make sure that the if then else itself is done correctly before I check the nested statements within the then branch or the else branch. So that's my approach. Okay, doesn't mean that you have to use the same approach, but you probably want to figure out which way works best for you. Alrighty. And you do have, yeah, go ahead. Yeah, go ahead. All right, so the C code may be intentionally a little bit difficult, but it really is not. There's a purpose to this C code. This C code fills in a tree structure in a breadth first manner. So it does fill in an application of a file system. This kind of approach may be appropriate, may be helpful, may be useful. Okay, but the point of the C code is really to present constructs like this and see whether you guys can look at this and analyze what it is supposed to look like versus what the code looks like in the actual in the code that is given to you, and find out whether it is correct or not. If it is incorrect, how do we fix that code? So that really is the purpose, and that's why I said earlier, you don't need to make this code run, and let alone running identically between the assembly version versus the C version, because my focus is not that. My focus is when I look at this construct and say, this is what we're trying to push on the stack. And if I have a intentionally placed bug in the assembly code, I want to see whether people can catch that, because with the right understanding of the C code and the right understanding of what the assembly instructions are doing and how they bunch up, how they are combined to get a particular thing done, I think that really should be doable. So the focus is not so much on the C code, but on the translation of the C code. This is not a homework assignment. This is not a case where I would actually test run the code. This is a case where I would look at the diff between what you guys turn in to what it is supposed to be, and using that I can assess whether people understand how to do the translation from the C code to the assembly code. That really is the focus of this class. Okay, everything that we have done before is really leading to this point. Not that the material that we talked about before, they are not useful on their own, but this is the part that really connects to programming in the future for all of you. So I hope that answers the question. Okay, because this is really kind of the only part that is a little bit difficult. But the point of this is really to see whether people can disassemble. I shouldn't say disassemble, because it does have a specific meaning in in assembly language programming. But I want to see if people can break down this kind of expression, really step by step, and figure out, how do we order, the operations, because how do we read this, right? And I said that in the class already. So we are trying to find the address of the element indicated by variable I of the member P, which is a member of the structure that is pointed to by a pointer, because that's how we use the pointer sign here. But that pointer in return is pointed to by point, and point is a parameter that is passed to this subroutine. So I know it is a mouthful to say, but there is a very specific order of doing things, because in this case we start with, there's no other way to start, okay, except to start with point. So we get to point, which is referring to the value of the parameter, but that is not what we need, because we know the parameter itself is a pointer to a pointer, so we need to dereference it once to get to a pointer to a structure. Once we have a pointer to a structure, we can combine the pointer to the structure with the offset to a particular member, add those two together so that we can get to the address of the member. So in this case, we'll get to the address of member P. But no one says that member P has to be a simple thing. It doesn't have to be an integer. It can be an array, it can be a structure by itself. But now that we have the address of this thing, which turned out to be an array, and the array has items, each one is taking up 1 byte, okay, and I is the index, how do we get to the address of that particular element? Well, you have a starting point. You know how big each element is. You just have to, multiply the size of each element, which in this case is 1, times, the index, and then add that amount to the address of P. And then we got the address already. So in C, it seems like you're getting to the address is one quote unquote extra operation. I think I explained this before also in class. In assembly language programming, we always get to the address of something first. If you need to get to the content or the value of that something, you have to do one extra step to dereference the address. So that really is the point of this test. Okay, I really want to test whether people can read something like this and be able to implement it. But I don't want people to implement it and give me the code. I want to use my own code that may not be 100% correct and see if people can spot problems. Because this way I can approach this in different ways and see if people can understand those different ways of accomplishing the same thing. So there you go. I mean, I am just telling you guys, from my perspective, what I am trying to do with the exam. So it does beg the question, how do you study for this class, right? So the way you study for this class is there are two aspects to studying and also to the strategy of, dealing with an exam like this. The first one is you want to learn by theory, but confirm by example. Okay, so let me say that one more time. You want to learn by theory. In other words, you understand what a push is. Okay, we allocate by decrementing the stack pointer, and then we store whatever we're trying to push to the location that we have just reserved. How do we pop? How do we return? How do we push the return address? And so on and so forth. Okay, so that's basically how, that's the theory. What is a label representing? Okay, when we have, let me switch to the assembly language side. When we have labels like these, what are they representing? What is node V? What is node P? And what is node size? When we have global variables n1, n2, and n3, where are they? How do we get to the address of those global variables? When we have parameters and local variables, why are these labels defined in this particular way? What does the call frame look like, for SD insert? How can we define, the label for n, in this particular way? Those are theory, okay? And given the offset to a particular thing on the stack, how do we get to the address of that thing? How do we get to the value of that thing? How do we dereference things? How do we store to a location that a pointer is pointing to? Those boil down to instructions. Okay, what is the LD instruction doing? What is the ST instruction doing? Does the CPR instruction do about the same thing as the LD instruction? What about the LDI instruction? What does it do? Okay, so all of those are bits and pieces that you truly have to understand, and they form the basis of the knowledge that you need in order to answer the questions. So once you understand those specific items, the theory, the sample programs that I have gone through, for the past 3 weeks at least, those are here for you to confirm your understanding. That's why I said, you want to confirm your understanding by example. But learning by example it does work for certain people because they can look at two examples that are designed to illustrate the same thing, and they can abstract that one thing that both sample programs are trying to illustrate. And that's good. Okay, the ability to do abstraction, to extract the abstract knowledge out of concrete examples is actually very, very important in this kind of occupation. But the sample programs are here so that you can look at a program that works and look at the instructions, look at the trace. Okay, don't forget that we have a method to visualize how things are accessed, changed, and modified as a program executes. So you can actually recreate, how the stack, got changed, how items on the stack got changed. How did we use a pointer to a structure and use that to access an element of an array which by itself is a member of a structure that is pointed to by a pointer that is by itself is also pointed to by a parameter. You can actually reconstruct the stack, using column C and be able to figure that out in using the trace analyzer. And that is why I made, well, part of the reason why I made the trace analyzer. So all of those are resources available to you to really just kind of understand, how everything works. And Paul also pointed out in a previous text channel about a document that I also think is very important, and hence, I think I have already, put some recommendations in the text channel already, and that one is caller callee agreement. This is a very, some people would call it very terse, but it really is the summary of, how the caller and the callee, talk to each other. What do they agree on? What can the callee assume that the caller had done already on the stack? When the callee returns back to the caller, what can the caller count on that the callee had done already, and what else the caller has to, clean up on the stack? That is really, really important. So, so I'm trying to point out, okay, the important stuff, in that are specifically useful in tomorrow's final exam. And are there any questions about any of the material that I have just talked about? And this requires, this really, really requires, a close tracking of the content of this class, pretty much since the beginning of this class. It really is, that's the nature of a class like this. Okay, I'm not seeing any questions. All right. So the key is available to you. I mean, I released it in the video already, and since you all have a copy of the original exam without the answers, so my recommendation is to slowly go through that video and make sure that you understand, how I evaluated the faulty assembly code. So it's not just about oh, okay, these are the places the tech made changes to, and these are the ones that are wrong. It's not just looking at those, okay? I think it is important to look at how I analyze the entire program. Because when I worked on this, I was not looking at the key. I was actually working on this as if I was a student, getting the question the first time. Now, obviously, I cannot undo what I already know, okay? But since my short-term memory is fairly faulty itself, okay, so I can't really just remember the key and go like, oh yeah, I remember I made it, intentionally put wrong code over here and also here. I didn't do that, okay. So the way I analyzed the code, I tried to spell out as much as I can the thinking process and what knowledge I was recalling and how I'm using that knowledge to analyze the code. So that's the best I can do, really, to illustrate, how to approach, those, that specific, question. Because not only am I not a mind reader, I cannot mind meld with anyone in this class either. I'm not Vulcan. I don't have pointy ears. If you don't understand that reference, it's okay. All right. Well, I'm not sure what to do, at this point because I was expecting, questions related to, um, the final exam sample question, and or specific questions about, okay, so what is in the particular register on a certain line of the solution. So I was kind of expecting stuff like that. Oh, here comes a question. Very good. Yeah, that will be office hour tomorrow. All right. Well, instead of just being awkward and me staring into the monitor and you guys hopefully staring at the monitor too, because some people may be multitasking and actually just be listening right now. Oh, okay, here's a question. Very good. Okay, so I'll let Curtis ask the question and see if I can answer the question. Are we getting a similar program? Okay, I hate to laugh like that because some people say, Batak, you're giving us a evil laughter. Well, evil is a label, and let's not use labels. Um, I try my best to make sure that everybody gets a different uh, question, and all those questions, should have about the same difficulty. They are just different. Oh yeah, yeah. They're similar in length and similar in terms of what kind of bug is included. Even the number of certain types of bugs are equal amongst all the questions. Oh yeah, I thought about fairness. When I do something like this, I definitely try to make sure that they're all um, basically about the same. Will it be conceptually similar to the spring exam? That is a very good question that I cannot yet answer because I don't have the final exam questions made up yet. But I'm going to suspect the format is going to be the same, very similar, if not the same. So the format is going to be about the same. I'll give you the C code, guaranteed to compile, guaranteed to run for those of you who want to use GDB to kind of figure out what the C code is doing. And then I will, basically give you the faulty implementation in assembly language. I will not give you guys ahead of time the number of faults. So you guys, you basically just have to look through the whole thing, not knowing, how many needles are in the haystack. Okay, but I guarantee there are needles in the haystack. Okay, that's the only thing I can guarantee. Um, so other than that, it's going to be similar, and I will do my best to have okay, let me switch back to the question here. So I'm going to try my best, to basically come up with expressions to test whether you guys know how to deal with structures, deal with pointers, deal with dereferencing, deal with parameters, local variables, getting the address of something, the differences between something on the stack, which is a local variable, versus something that is not on the stack, which is a global variable in the examples that we have gone through. I will test whether you guys understand, how to translate control structures, how to translate, Boolean expressions, how to specify return value, how to push arguments, and so on. I mean, those are all the concepts that we have talked about in this class. So I'm going to hit, you know, most and many of those concepts and basically design scenarios that you kind of have to kind of figure out what's wrong with the code and whether it's wrong first, and then what is wrong with the code and how to correct it. I do have to give you not you individually, but give the class a warning of if a change is not needed and it is indicated, it can lead to deduction of points. Because I don't want you to see an answer that is just blanketing the whole thing. It's like, okay, I'm going to replace this entire chunk of code with my own code that I know is right. That is not the point. The point is, can you spot problems with the code that I have provided? And if so, how do we fix that code? So I do have to warn people ahead of time because that approach is not going to work. So you have to work with what code is given to you, spot the problems, and fix them. So I hope that answers Curtis' question. So I almost forgot. This is super important. Um, in terms of percentage, 37.5% of everything combined in this class is a C, which is a passing grade. I know most of you are saying, but I don't want a C in this class. I want a B or an A in this class. Yes, I understand that. But technically speaking, C is a passing grade that will let you move on with the program. So the final exam by itself is 40%. Okay? So you think you do the math, right? 37.5% is less than 40%, which means in theory, okay, I have to emphasize this is in theory. In theory, someone can turn in no homework assignment whatsoever. Basically ignore all the labs that take rows, otherwise those people would be dropped already. Totally flunk the first and the second exam, but ace the final exam, and that person would actually be passing this class with a letter grade of C. There had been one attempt like that in the past, and it was almost successful. Except in that particular case, I specifically said in the exam no copy and paste into the Google Doc. Well, guess what happened? Yeah, copied and paste the entire program at the very end. So I was not convinced that that particular student actually did everything, but that was besides the point because the rule was no copy and paste from an outside source. So that was that. Hoping for C likewise and so on. All right. So I know I am not. I'm just your professor. Okay, I'll just put it that way. Okay, I'm not gonna get into trouble with this one. So I'm just your professor, but I will share how I look at classes and how I look at grade. Now, if you don't want to listen to me, you can always just kind of mute me. And I'm going to turn my camera back on because I think my facial expression may add to it. Although I was told that I don't emote a whole lot, so it may not actually be it may not be adding too much information. All right, so first thing first. Why are people taking classes? Okay, so that's the first question. And I think it is not uncommon that the answer is going to be, I need this class to get a degree, in order to transfer. Okay, so that's a very good reason. I cannot argue with that reason. Okay, but then the next question is, why is this class in the program? Why is this class a part of a degree? Well, because traditionally, I think the four-year universities want this class as a lower division class, and since community colleges can only teach lower division classes and cannot teach upper division classes, that's why this class is in the degree. But that doesn't really explain the actual reason why this class is in a degree. Okay, you may not be able to see why this class is useful because you are on your way to become a developer, a software engineer, or a computer scientist. You're not there yet, okay? You may not be able to see the importance of all of these topics. But I can tell you, because I'm older than most of you, if not all of you, by a good margin, that I find this stuff useful. I wished my professor, when I was taking this class, would actually go through the stuff that I went through with this class. So it is what you learn in a class that is important. It is at least as important as the actual grade that people are getting out of a class. I know this is just how I look at things, and people do not have to agree with me. But I think if people are taking a class and it's painful, if it's painful because of the professor, I get that. Okay, sometimes it just doesn't match. But on the other hand, if it's because of the content, if it's because of the material in the class, that to me is a flag. Okay, it's a huge flag, waving in front of me and going like, really? I mean, this is something that might need attention. So that's all I'm gonna say. Let me go back to the text channel. All right, so to address some of the concerns in the text channel, um, I don't judge people because they have to take a class again, and I do not. I want people, everybody to don't judge, okay? Because okay, I could not get a passing grade, in this semester. So forget about the judging part. Focus on um, the reason. Now you can say Tech is just a terrible teacher, okay? Well, that's a good reason. Take it from somebody else, okay? Just don't get hung up on something that you have no control over, okay? Think of a solution to the problem. But on the other hand, if it is something like, but I don't understand some of the concepts, in this class, that means, if you take the class again, you have, um, it will be the same material. Okay, I can guarantee you that every semester I teach this class, I'm trying to teach exactly the same material, even though it's taught slightly differently from semester to semester. So if it's about the material, and okay, first of all, okay, let's roll back a little bit backwards. Okay, this is a summer class. It's 8 weeks. We're compressing a 16-week class into an 8-week class, and it's a 4-unit class. And I can tell you that by itself makes a huge difference, because as an 8-week class, we have 4 lectures continuously, contiguously, okay, Monday through Thursday. And with a class like this, if somebody has a problem, with one particular concept, just I'm not quite getting this concept, I just need more time to, digest the concept. Guess what? The next day, the next concept is built upon that concept. So it really hurts, okay, when someone says, okay, I just need a little more time to think about this to understand the concept. I can totally understand that, but with the 8-week class, there's just no opportunity to do that, and it's really, really hard to catch up. A 16-week class is still pretty packed, okay, but it's not as unforgiving as an 8-week class. So I think, moving from a summer session class to a full semester 16-week class, that should make some difference already. So I'm only talking about this, from the perspective of, what aspects of a summer class, can contribute to this class being a little bit, challenging. Um, okay, so yeah, the pace is definitely fast with this class. I kind of emphasized that on day one of this class when I went over the syllabus. It's going like, yep, this class is going to be pretty fast, when it comes to the moving of the material. Um, okay, so that's that. Okay, so once again, don't judge. Okay, I know some of you, or some people, I shouldn't say some of you, because my sister is one of those people. My sister aced all her classes in high school, never got a bad grade. Okay, um, and then she went to take organic chemistry and flunked that class despite her best effort, and she was devastated. Okay, so I was going like, well, don't judge yourself, because she was judging herself. She was looking at herself and go like, I am a failure. No, it simply means that you didn't quite get all the material. Take it again. Next time, just focus on the material that you didn't quite get the first time. Focus on those, try a different strategy to understand the material. And that's it, right? I mean, it really just boils down to, okay, maybe I didn't quite get all the material, and I'm going to find a way to understand the material. All right. Uh, yeah, so I hear you too. Having a full-time job and taking this class in the summer, I mean, that's really a lot. I mean, I have to say that's really a lot. If you have a full-time job, even a part-time job combined with this class is a lot already. I did some calculations. Remember, at the beginning of the semester, I calculated how many hours people are, need in order to meet the time requirement, that the college has determined. Okay, and it was like a part-time job. I mean, you really need to spend, I cannot remember the exact number. but I think it's 20 plus hours every week, to keep up with this class. That's the amount of time that people should be spending in this class, and with a full-time job and family and stuff like that, I understand, it may not be possible, and that's why I said, don't judge yourself, okay? Because there are all kinds of factors that can contribute to the grade that people are getting. So it's not because, there's no reason to judge, people, or yourself, you know, I shouldn't say yourself, but okay, just don't judge, okay? You don't use words, don't use labels, and focus on, you know, um, the reason, okay? What am I not getting, okay? And how can I do better, okay? And one thing you guys can help me is to ask questions. Okay, if you read ahead of time, which also takes time, and I understand time is something that some of you are really, really running out of, but that's kind of the resource that is needed in a class like that. In this, yeah, with a toddler, oh man, that I have teenagers now. Okay, but they were toddlers once, so I fully understand what that means. Yeah, so don't worry. I know you have to take the class again, and it might impact some of the other things that you want to do. Just take it again. Okay, don't judge yourself. Look at the grade and go like, okay, I'm not quite getting all of the material, but I have reasons. Okay, so next time, see if you can align resources. Make sure that you get enough time. Make sure you have a schedule so that you give yourself enough time to study, to read ahead of time, and so on. Um, and try again. So not really sure how much that is helping. I'm just telling you guys what I think, which is not necessarily how you think, and so it's okay. I mean, if you do not agree with what I just said. Oh, yeah. That's also something that is out of control of individuals, right? I mean, you have to move. So as I said, there are circumstances that can create a situation. Now, am I a bad teacher? Possibly. I don't know. I mean, I don't go check on my ratemyprofessors.com. Um, but I really do try my best to get the material across, by using sample programs and try to get you guys to ask questions, after I have demonstrated certain things. uh, okay. All right. So I'm going to give you guys, one more resource that I think is really useful. How you want to use it is entirely up to you. Okay. It is, okay. I cannot really, truity dot com. There we go. All right. It's not loading. Come on, load. Hmm. That is strange. It is not loading. Okay, so what I want to do is to kind of show you okay, let me see if I can do a search here. Yep, same thing, it's not loading. Oh, this time it is. Okay, great. So this is Truity, the website, the URL is just, the same thing, truity.com. They have paid assessments, which I think is worth paying for, but you don't have to pay. So what you want to do is to go to Career Profiler. Okay, so that's a free test. You just have to answer a whole bunch of questions, and it will tell you what kind of occupation, uh, you how you align with different types of occupation. So this is one really good resource. I also want to point out one more thing. which is not to mask my own, weaknesses in teaching a class, but I do want to, show you what is a divide class college. Let me see if I can find reference to that. Nope, that's not the divide that I was trying to find, and that's not the class that I want to refer to. Okay, so with every major, there is one or two classes where they're called the divide. Okay, so if you think about a geographical structure like a mountain, the ridge of the mountain is called the divide because when rain falls on one side, it goes to one river, and when rain falls onto the other side of the slope, it goes to the other river. It's called a divide. CISP310 assembly language programming are these are the divide classes in computer science. Okay, I understand right now the draw to this to the major of computer science is because there's a lot of money. Okay, occupations, there are a lot of opportunities and whatnot. That is great. Okay, I have to be careful with what I'm about to say. It is important to have an alignment between the aptitude of a person and the occupation they want to pursue. Now, I'm not trying to tell anyone to give up. Okay, that is not my message. Okay, because as I said, there are many other factors that can contribute to how to the grade after a particular semester or session. But the alignment is important. Okay, so choosing a job only because of the income and forgetting and ignoring the alignment of aptitude, personal aptitude, can be painful. Okay, that's all I'm gonna say. So I recommend that you guys kind of take this test and just kind of check it out. Kind of check it out. That's all I can say. Because I don't want to get into trouble. I don't want to I don't want to be perceived as telling people to give up because that is not the message. All right, so we are running out of time. Oh, okay, so that's the under and over representation. That is interesting. Who posted that? Colton. Okay, thank you, Colton. So if you're reading the chart on the text channel, on the four-letter stuff, those are the Myers-Briggs type indicator MBTI types. So INTJ, INTP, ENTP, those are all basically specific types of people. So there is a distribution. Okay, so we cannot really deny that there's a distribution. Now you can kind of question, but what is the sample, right? How do we get people to participate in this particular kind of statistics? So there's a question about that. Maybe the data or the graph that we are looking at here is not necessarily accurate. There is a chance. Okay, so you guys have to check into that. Okay, find out how they collect the data. But if the sampling is correct, then there is a strong correlation between MBTI and representation as a programmer. In computer science, most people are developers or software engineers after they get a computer science degree. A very, very small percentage become actual computer scientists to do research. So there is that. Okay, and I'm not sure whether you guys know my MBTI, because I think I told you guys at the very beginning of the summer session already, and some of you may remember that, and it is not INTJ. Yeah, some people mistake me as an INTJ and go like, no, I'm not that kind of an asshole. Yeah, because I have people telling me, oh, I'm of this particular type and I don't really like it because I don't want to be an asshole. I go like, no, just being of a particular type doesn't mean you're an asshole. Yep. Mm. All right, so we are running out of time in the lecture, and I have been bullshitting for a while. Not intentionally. I think these are things that everybody should think about at a certain level. So if you want to continue the discussion, I'm more than happy to correspond to each one of you using direct message. Otherwise, I am going to sign out, and stop the screen sharing and also the streaming. But I'll be online, because that's my obligation is to basically, make sure that I'm still online for the next 80 minutes. Cool. All right, so I'm just going to sign out, but I'll still be paying attention to the text channel. And even though my office hour is just 1 hour tomorrow from 11 to 12, I will try to get back to you guys if, whenever I can, okay? But I can't really be answering Discord the entire day. I still got other things to do. But I will do my best to respond to your text messages if I can. All right, so I'm